R5-Objective 3 is factoring trinomials. I'm going to break it into two kind of ideas. And the second group that I'm going to cover, there's more than the way that I'm going to show you. And if you had me in class a couple years ago, I probably showed you a different way. Ultimately, how you factor trinomials of the second part that I'm going to show you in a little bit is up to you. So long as you get it right, I don't care. Okay? But I'm going to piggyback on what we were just doing with the factoring by grouping and keep using that. Again, if you're comfortable with another method, that's fine. Okay, the first part is fairly easy. So we're going to talk about trinomials with a leading 1, and then we're going to talk about trinomials without a leading 1. The leading 1 problems are pretty easy. Okay, it's the second group that's a little tougher. So I'll go through the first part fairly quickly. The second part we'll go a little slower on. Start with the leading 1, factoring trinomials with leading 1. So here's what that really means, right? We've got 3 terms. It's a binomial. It's got or a trinomial. It's got to be in descending order, and the first coefficient, the leading coefficient after it's in descending order, is a 1. This is typical form. Okay, you've got x squared plus bx plus c, where this leading coefficient is a 1. Okay, when we have problems that come in this form, they're fairly simple, and there are a bunch of examples of what I'm talking about. You can write as much of that down as you think you need to. But problems in this form are fairly simple, and you're going to be really good at these if you're not already. Okay, so I'm going to kind of fly through that a little bit, and then we'll talk about some tougher ones. Okay, so the problems in this form, the basic strategy is this. You're finding factors of the last term, and we're including the sign. So in this case, positive 15, that combine to give me positive 8. Right. In a case like this where the last term is positive, the factors that you're going to use will always be the same sign as whatever this number is. In the next example, it's going to be negative, so their signs are going to be opposite. Okay. So what are the factors of 15 that add up to 8? 3 and 5. Okay. And so all we do is you find the factors of 15 that give you 8, 3, and 5. So the front terms are the square roots of this. The last terms give me 3 times 5, which is 15, and then the outside and the inside terms, 5x, 3x, give me this 8x. You guys have done this before. Okay, and this is not an issue usually for you, and these are the easier ones. Okay, the other type of example is when this last term is not positive. Now, if this was positive like this and this was minus, these would just both be minus. Okay, so let's look at that one. Here's one where it's negative. So I'm looking for factors of negative 48, which means one of them is positive and one of them is going to be negative. Okay, another way to think of it is the factors of 48 that subtract to give me 13, right? So what are those going to be?
16 and 30.
Positive 16, negative 16. One of them's got to be positive, one's got to be negative.
Positive 16, negative.
Positive 16, negative 3. Okay, and so that gives me negative 48. But when I add, I get positive 13. Okay, so again, if this last term is negative, the signs will be opposite. Then you got to figure out which one needs to be positive and which one needs to be negative. That's pretty straightforward and simple. Okay. The reason I went through that at all is because this idea of finding factors of a number that add or subtract to another number are key when it comes to factoring trinomials without a leading 1, and that's a little tougher. Okay, and we're talking about now we're talking about trinomials in this form, where a is not 1 anymore. Okay, now we're going to have a number we're going to have a number there. Okay, and so factoring these trinomials is a little bit tougher. And you guys, like I said, you maybe learned guess and check, find the factors until it works out. A couple years ago, you may have remembered me teaching you the box method. I'm going to show you using grouping today. Okay. And since we just got off working with grouping the other day. Okay. Ultimately, again, how you factor is up to you, so long as you factor it correctly. There's multiple paths in this particular problem. I'm going to show you one. Okay. So I'm gonna give you some steps, okay, that you need to follow. Okay, and once you follow those steps, you're gonna wanna do that pretty much every time. Okay, first off, you gotta make sure that the trinomial is in descending order. Okay, if it's not in descending order, it's gonna be really hard to factor. So, if it's not in descending order, put it in descending order. Okay, that's gonna be the first step. Now, this is also assuming you've already factored out a greatest common factor, that kind of thing, okay? If that happens, if there's a greatest common factor, always try to factor that out first. Second step, you're gonna multiply A times C. And that's where we're gonna use that concept of what we did for with a leading one. Find factors of that add up to the middle. Okay, because after you multiply A times C, you're going to get that product, AC. Okay, and we're looking for factors of that. So find the factors from the product from number 2, okay, AC, that combine to give us BX. So we add one little thing. Instead of just looking at the last term and finding factors of it that combine to the middle, we have to multiply A times C first, then find factors of that product that combine to give me that middle. That's the nuance that's a little bit different. That multiplication has to happen first. Okay, and once we do that, then we're going to be in good position to finish this factoring up. Okay. So once you find those factors, you're going to rewrite BX using those factors. And this will become a little more clear when we go through an example. Okay. And then, of course, after you write it, you're going to factor by grouping. And again, if you don't like using grouping and you have a way where you can figure it out in your head, guess and check and find the numbers to factor that trinomial, you are welcome to do that. This is a strategy, however, that will work every time and doesn't require guess and check and doesn't necessarily have to be super frustrating for you. Okay? So here's an example, okay? So it's in descending order, so we're good. Okay, notice that I do not have a leading one. So my first move is to multiply 6 times 7. Now over to the right, of course, I wrote 42 because that's what 6 times 7 is. Right, so now I'm looking for factors of 42 that combine to give me 23. So you got to think through the factors, and if you can't think through the factors and find it, make a list. List all the factors. And this is where I typically would make a list of the factors. Okay, anybody think of what the factors are of 42 that add up to 23?
21 and 2.
I'm sorry?
21 and 2.
21 and 2. Okay? So essentially what I'm going to do now, since 21 times 2 gives me 42 and it also combines to give me 23, I'm going to rewrite 23x using these numbers. Okay? So I'm just going to write it as 21x plus 2x. And what I've done is create a polynomial with 4 terms, and now we can factor it by grouping, just the way we did on Friday. So go ahead and finish that up. The one thing I can tell you is if you can find the factors, it is factorable. It will work. Sometimes you won't be able to find the factors, and sometimes those factors do not exist. That they can't multiply to give me the one number and add to the middle number. Okay? You just got to be careful, because if you ever have this as a negative, this becomes negative, which means those two numbers, one's positive, one's negative. Okay? Group. Keeping in mind, if this was a minus, you'd have to slide the minus inside. What's the greatest common factor here between 6x squared and 21x? 3x. What about over here? What do I do with this? Yeah, but there's a 1. I need the 1. Okay, here's what's important. I need the 1. Because right when I pull this 2x plus 7 out, there has to be a second part of that other binomial. So in grouping, if there is nothing in common other than a 1, I still need the 1. Right? Because then when I finish it up, instead of it being 3x plus 1, if you left the 1 out, you might think it was just 3x, which it's not. Okay, that's a whole different problem.
Does the order matter?
The order does not matter. So long as you've got, so if you put 2x plus 7 and 3x plus 1, that's fine. Again, you could use the box method doing the same thing. It would accomplish the same thing. If you can guess and check until you find the right factors, for example, you know for that you have to have a 1 and 7. Those are the only factors of 7. These back two numbers have to multiply to 7. The front two numbers have to multiply to be 6x squared. So you could have tried 6x and 1x, or 6x and 1x here, or 2x, and until you found the right combination, you're welcome to do that. Sometimes that takes a little time. This method guarantees that you'll get to the answer quicker if you can find the factors. Okay. Again, which method you use is up to you. I figured I'd show you grouping since we just covered grouping a little while ago. Okay.